In the last part of this chapter, we want to look at, we're going to call them designer molecules. We're going to look at some molecules that do not occur in nature, but some that have been made for special reasons. So we're going to look at the reasons and look at those different structures. These designer molecules, well, we want to be able to enjoy the taste of calorie-rich food without getting all of those calories. So we're going to look at some different designer molecules that are used to mimic fats or carbs to give us that taste or maybe that feeling without giving us all of the calories. The first designer molecule we want to talk about is olestra. And olestra is going to be used to make something fat-free. We want something that gives us the taste and the feel of fat, makes us feel full, but it passes through the digestive system untouched. Now, if you remember what a fat normally looks like, it's a triglyceride. So we have 3 carbons. And then each of these carbons is going to be attached to an ester group that has this big long R, this big long side chain. I'm going to be lazy and I'm just going to put an R on here to represent that fatty acid, but remember it has an ester in there also. So instead of having this fat that our body can figure out how to break down, what olestra does is it starts with sucrose. So here's sucrose at the bottom. It's a carbohydrate. And if you notice, we have these little OHs. It's going to take this R group that we had up on top, and it's going to put it right there where that OH is. It's going to replace the OH with a fatty acid. So then we have these really long fatty acids coming off of this glucose saccharide type unit. And when it gets into our body is like, oh no, I don't know what to do. Remember, to break down a carbohydrate, we have to have an enzyme. Well, there's no enzyme in our body to break down this carb with these big, long, fatty acid chains on it. So it'll just keep going through our system and it's not absorbed by our system. Sugar substitutes are a very common type of designer molecule. So here's the first one we want to talk about. This is sucralose. This is in Splenda. This one's going to start off with sucrose. So we have that down at the bottom. But what it's going to do with this sucrose is it takes 3 of these OHs and it replaces them with a chlorine. So when it gets into our bodies are like, I don't know what to do with this anymore. And so again, it's just going to go through our intestine and it's not going to be absorbed. So this is going to provide very, very few, if any, calories. Now, it turns out, because of the changes that are made on this one, we identify this as being extremely sweet, like 600 times sweeter than regular sugar. So because of that, it takes very, very little of this to be placed in our foods. Again, so Splenda is one of our sugar substitutes. Here's another sugar substitute. This is aspartame. This is a sweetener, but instead of being based on sucrose, this is actually made with peptides like a protein has. So we have our basic protein structure, and then we have our little R, these little side chains, which are different for everyone. So we have 2 different amino acids that are going to be used for this particular one. Now, this has kind of an interesting history. A researcher, James Slatter, was working on a treatment for stomach ulcers. As he was turning his notebook pages, he licked his fingers. That's why you should never, ever, ever taste things in the lab. But he noticed his fingers were really, really sweet. And so he started tasting everything he had touched in the lab and realized that this was actually it. You'll see a similar story actually for saccharin. Saccharin has a different chemical structure. You can look that up on your own if you want to. Now, aspartame is about 200 times sweeter than sugar. So again, we use very, very little, almost none of it. And so it has almost no calories. This is going to be in a lot of your diet. Drinks are going to contain this. Now, am I saying that designer molecules are great and we should go eat designer molecules all the time? You know, just drink water. Water is really good for you. Our bodies don't really know how to handle this. Some people it can handle a little more than others. Personally, I don't like diet drinks. I get a lot of aftertaste after it. I would much prefer to just drink water. I don't need that sweetness in my drinks. Just give me my good old water. But you have to make your own decision. There's a lot of chemistry behind all these things, so it's pretty cool.